Hey everyone, and welcome back to the channel. This is Philip from Morales, and in this little series we're going to build an NFT game, something that has become very popular throughout the years, especially on Ethereum, all starting with CryptoKitties back in 2018, I think it was, where you can best and breed these digital cats and you can then play with them in different games. And there are all sorts of different games with NFTs. You can have in-game items, you can have different type of strategy games where you purchase land and you build on that land and so on. And everything is represented by, there's some part of the game that is represented by this NFT. And here in this series, we're going to build a simple NFT game. We're going to have some sort of pet that has special properties depending on the token, and where you can feed it and you can fight with it. Really, you can implement whatever you want. We're going to implement some basic features, but you'll have to do some of the lifting yourself with your creativity. What should we be able to do with this little animal that we're gonna have our tokens represent? And we're gonna start by developing a smart contract. And that's actually not as hard as it might sound, because we're gonna use Zeppelin to create large parts of it. And we're gonna adhere to the ERC 721 standard. So in your editor of choice, let's go ahead and open up a terminal, and of course I've created a new directory here. And then here we're going to go npm init to initialize the node package manager. And you're just going to skip through all these questions like that. And then once that's done, we can also install Zeppelin. So npm install at Zeppelin/contract. Okay, that will give us the entire Zeppelin library of contracts, and we're going to use their token 721, this one right here. Now I have a lot of the code already done. We just need to do a few extensions. What we're also going to do is we're going to init Truffle init. So you need a few things in order to start here, as you've already seen. You need a node package manager, node, and you need Truffle. Now we also have our Truffle folders, contracts, migrations, and so on. And if you need a basic Truffle or Solidity tutorial, there are plenty of those on YouTube. So I'm not going to go through that. You need some basic knowledge of Solidity in order to be able to complete this tutorial series. So we're going to create a new file in our contracts directory. We're going to call it token.sol. And let's start with the version. So in this video, we are at version 0.8.0, but that might change depending on when you watch this video. And then we need to import a few contracts from Zeppelin, and these are located in /node modules /at Zeppelin/contracts /token /ERC 721 /ERC 721.sol. When we import that, you can navigate to those contracts. So we get this contract right here, where we have the basics, name, symbol. We have the mappings that we need in order to figure out who is the owner of a specific token ID. And then we have all of these other ERC methods that are standard for ERC tokens in general, approvals, and we have transfers and balance and name, symbol, approve, all of these, all this good stuff. And you can check that out on Zeppelin's website, or just Google for the ERC standard 721, and you'll find all of the methods and variables that we need. So we don't have to code that ourselves. Then we're going to import as well. We can copy this entire thing actually. We're also going to import contract/access/ownable.sol, so that we can have some sort of management of permissions here. Then we're going to create our contract. So contract token is ERC 721, so we inherit from that contract and ownable. And once again, if you're uncertain about inheritance in Solidity, search for some Solidity tutorials on YouTube, because I'm not going to go through that here. And at the core of our token will be a struct that we will call pet. So we're going to build some sort of pet animal here, or some sort of creature. It's not going to be a real animal, but something that we have to that has unique properties, and that we in some way need to take care and feed, and we have some sort of upkeep. That's what I was thinking for this basic game. And then we can extend it with where they can mate with each other. We can get offspring, we can get new pets, we can have DNA, You could have them fight each other like Pokemons, whatever, right? And you can call this whatever you want. I'm going to call it pet. And this could have whatever properties you want. So I just came up with, okay, it can have damage. So if it's a fighter pet, it can have damage. It could also have, or this can be uint 8s because we don't need to have such a large scale. So this could be anywhere from 0 to 256 if it's a uint 8, and that I think is enough for 255 probably. This should probably be enough in order to label or characterize whatever damage that the pet has. Then it might have some sort of magic ability and whatever you can come up with here. Then I'm also going to have a property here that is uint 256, and that is the last last meal. Okay, so when this animal last got to eat. And then another property, because this is more like a state, another property is uint 256 endurance. So this would be how long this pet will be able to go without food. So we need to provide food for this, and what my original thought was that if we ever, get past its endurance, meaning let's say that this is, okay, so this can be 1 day, 24 hours without food. If we fail to feed it within 24 hours, it will die. And that's why we need this last meal tracker. That was I saw as some, some game logic that could be fun to do. Then we also need to introduce a new mapping in order to map from a token ID to a specific instance of this struct. So we're going to have a mapping from int 256, which is the token ID, to a pet struct. And this is going to be private, and we're going to call it token details. So in the ERC721 token contract, we already have mappings like owners, which maps from the token ID to the owner address. We have things like, okay, the address is mapping to how many tokens that address has in total, because remember, all of the token IDs are unique. And we have token IDs for approvals, not very important in this case. And we can select whatever we want for the token IDs, but we're gonna just name them, we're gonna start at 0, so the first one will be ID 0, and then we'll just go upwards, because that's the easiest in terms of keeping track of how many we have. And we also need a constructor, right? Where we're gonna take in string memory names. This is the name of the token, just like CryptoKitties has a name. This also needs a name. Then string memory symbol. And apart from, these properties are things that our parent constructor needs. So the constructor here needs the name and the symbol. So we're just going to pass them right into ERC721 constructor with the name and the symbol. Okay. Then if we want to add anything later, we can add it in the constructor here. But for now, we're going to leave it empty. Another thing that we need is to be able to mint new tokens, right? So how are the original tokens going to be created? Well, in this case, we're going to do it so that the owner of this contract, the creator of this contract, can mint tokens. So in order for us to mint tokens, we need to provide what the damage should be. So these are inputs. And whenever you generate these, you can, of course, make sure that these are randomized, because you're the owner. So if you want to create 100 tokens, you can make sure that you input random numbers here so that you actually get some fun variation in the properties of the token. This we call the endurance. And it's going to be public, and it's only going to be available for the owner. So this is a modifier from Open Zeppelin, the ownable contract that we inherited. And what we're going to do here when we mint tokens is just to call the underscore safe mint function, which is a function in this parent contract here that mints tokens. So we have this mint function, and safe mint is a wrapper around that just does a few more checks so that the token was actually received. So that it's not sent to an address that can't support this token standard. But we call underscore mint, and that just creates a new token, and it adds it to the different mappings that we need. It emits a transfer event and so on. So we can call that event because all of these functions are internal, so they're not publicly available for anyone to call. So we need to expose that as a public function, but we set it so that only the owner can execute it. And then we call this safeMint function, and for that we need the address of the person who's going to own this and the token ID. We're not going to fill in any data because we have no extra data to send. So message.sender is going to be the owner, and then token ID, we want that to be 0 the first time, but then we want it to increase. So we need some sort of variable here to keep track of that. So we're going to create a variable here that's just unsigned integer next ID is equal to 0. And we use the next ID as the ID. And then after this, we just say next ID plus plus, so that next time we come into here, it will be 1, so that we always increment it. Apart from doing this, we also need to create the actual struct, right? Because that's what we actually created. So we're going to do that here as well. We're gonna create a new pet. We're gonna input the damage, the magic, the endurance. Oh, we have one more thing. Yeah, so we have the last meal as well. So here we need to input the last meal will be block.timestamp. So when we create it, its last meal will be when it was created, which is block.timestamp, because that is the current time. Okay, and then we have endurance. So when that's created, we just need to set it in the token details mapping. So token details for, oh, we need to move this down. For next ID can be equal to this new pet that we created, okay? So now we can mint new tokens, all right? And we're gonna try this out in a sec. We need a few more functions before we actually wrap this up, because then in the upcoming videos, we're gonna focus more on the UI. We're gonna build a nice game. But now we need a feed function as well, so that we actually can increase the last meal time, okay? So this is the interaction that we will do with our pet, all right? And what we're gonna do is we're just gonna set the token details, so the actual struct. I'm gonna set last meal equal to block.timestamp, so we're gonna bump this up to the current time when we feed it, which makes sense. And then we can put all types of limitations here. So what's gonna happen if we let our pet die, meaning that the endurance runs out? We shouldn't be able to feed it, for example, after it's already dead, basically. So if we killed our pet by not feeding it, we should not be able to feed it and bring its last meal time up, because then it's already dead. That's sort of the incentive to keep it alive, right? You shouldn't be able to do anything with it once it's dead. So we need to put a require statement here that the pet has not passed its last meal time plus its endurance. So let's do like this. Pet storage pet equal to this. Then we can use that here and here. So pet.lastMeal plus pet.endurance must be bigger than block.timestamp. I think that's correct. So whenever it last ate, which is the time in the past, plus its endurance, it must be bigger than where we currently are, because otherwise we've already gone past that date, and then we shouldn't be able to feed it anymore. Okay, perfect. Now we have some actual game logic here that incentivizes us to take care of our pet and to feed it, and then we can just continue to build upon that. Maybe we should also implement so that you can't transfer it if it's dead, and that's very easy as well, because there is a function in this contract that's called before token transfers, and this will be executed anytime before we do a transfer, because it is called from the transfer function. Let's see if I can find the transfer function. Here it is. It will call here before we do the actual transfer, and this can be overridden because we inherit from this. We can copy this, we can implement this here. We'll just say that this is override, because it overrides a function in our parent contract. And here we'll do the same thing as here, basically. We'll just require that the pet is still alive. And otherwise it will throw an error. And we won't be able to transfer the tokens. That's pretty interesting, you know. If we don't take care of our pet, not only can we not feed it again, but we also cannot transfer it to anyone else. So it's very much a dead token, right? It can't be worth anything because it can't be transferred. Something that I realized after we did this before token transfer function is that we need to switch the order here in the mint function. So safe mint needs to be done after we have set the token details to this new pet, because in the safe mint function, it in the end calls the transfer function, and that will call this function, which will try to get the pet from token details. So we need the token details to be set before we call safe mint. So that's the logic of our token, and we can now see if this actually compiles. So let's run Truffle Compiler. All right, so I need to specify my Solidity version. So I'm going to go, if you get this error about Sol-C not being the right version, going to Truffle config. And let's go down to compilers, Sol-C, and set this to 0.8.0, and then uncomment this line. Then compile again. Endurance not found. What did we call it? Did I misspell it? This should be not capital P. It's this local or stored variable reference that we're looking at, not the actual type of the struct. Try that again. There we go, nice. So that's it for this video. Now we have the contract done. That's all we need for now, at least. We'll see what we'll implement in the future, but in the next video we're going to deploy this, and then we're going to start working on the actual interface of the game. So we're going to make it actually functional. We're going to have an actual image of our pet, all of that stuff. We're going to have user authentication with Morales. We're actually going to make it look good, I hope. So I hope you enjoyed this short video. This is more like how to create an NFT contract from Open Zeppelin, and we added our own game logic. So I hope you enjoyed that. If you have any questions, leave them in the comments below. Also, don't forget to check out morales.io, because that's what we're going to use later on for our user authentication especially, and also to handle events and so on. And there we also have an amazing community, so make sure to join the Morales beta and get inside our community. We have a ton of resources there, and you can get a ton of help from other developers. So make sure to check that out by clicking the link below, and I'll see you in the next episode of this little series. Thanks for watching.